Good morning, everybody, and welcome to Core 1 Webinar Week 14. This is a live webinar, or a non-live webinar this week, because we are doing testing today. So I cannot be here in person, but what I want you guys to do for this week is to do like we normally do. Go ahead and open a new tab, go to Quarter 2, Week 14, and click on the webinar and discussion page. And I'm going to show you guys actually what that is going to look like this week, because we are now starting, and you can see on the screen, Unit 3. And Unit 3 starts with Week 14. So you would want to go to Unit 3 like I'm doing. And then you would see Week 14 in here. Go ahead and click on that, and then click on the webinar and discussion. So hopefully right now you're watching this because you already did this, but here is where your discussion is. So what I want you to do first is to go in and try to answer the question. You can do it any way you want. You can, plug and check, guess and check, come up with some kind of equation if you want to, but that's the fun of it, is see if you can figure out the answer to this webinar question on your own. So while you're doing that, go ahead and pause this recording, and then when you're done responding, come back. So then at the end of this webinar, when you come back, I will walk through this problem with you, and at the end of the webinar, then what I want you to do is go back into your discussion in Schoology and write what you learned. What did you learn from this? How close were you? Maybe reflect on that, and that's what I want you to do for this week. So if we look at our objectives, the objectives for this week are to create equations to represent a contextual scenario. And you may not have created equations, and that's perfectly fine. That's what we're going to do together. And then you're going to analyze the solution to a contextual problem, which is on our discussion. Okay, so it's no good coming up with an answer if you don't know what it means. All right, so hopefully you guys have posted your discussions, and now you are back, and let's go over the problem. So here's the scenario. We have two skiers and they are racing downhill at these speeds. Skier 1 is 100 feet every second and skier 2 is 110 feet every second. The situation though is that skier 1 starts 5 seconds before skier 2. Another way of saying that is skier 2 starts 5 seconds after skier 1. The course is 5,000 feet long. That's our distance. Will skier 2 pass skier 1? And then, most importantly, how do you know? Because I want to know what you're thinking. If you just made a guess, you still came up with a guess for some reason. So why did you guess that way? How do you know? Some of you guys may have tried to do it mathematically, and that's super, that's great. And so what was your mathematical thinking? Okay. So a really important equation that I wanted to bring up is this distance equals rate times time equation. And that really is a direct variation equation, something that you guys just had. If we think about distance equals rate times time, if I were to write this out like I do a normal y equals mx plus b, I could say that my distance is y equals, and then our rate is our constant of variation, and then our time is our x, right? So our distance is equal to our rate times time. Another way of writing that is we could also write it as y equals mx. So this is already a familiar equation to you, and it's very commonly used for any type of distance and rate type problem. So distance equals rate times time. So that makes this problem a lot easier if we use this equation. So if we look at skier 1, so we'll call this 1 for skier 1, he is going at a rate of 110 feet per second. So if I make my equation for him, distance equals 100 feet per second, right? Distance equals rate times time. We could say that's his equation. And then we could also look at a skier number 2, and we're going to ignore the fact that he starts 5 seconds after skier 1, but we could simply, very simply, just say his distance is equal to a rate of 110 feet every second. And we could give these very simple equations like that. Okay, and we could use this to help us try to figure this out. Well, we know the distance. The distance here is 5,000 feet. So if we take skier 1 and we say he's going to travel 5,000 feet, how long will it take for him to get down the mountain if he travels at a rate of 100 feet every second? Okay, so all I've done is I've just plugged in skier number 1. I plugged in a distance for him. Move this guy down. And now we're going to solve for time. We're going to see how long it takes him to get down the mountain. So if I divide both sides by 100 in order to solve for t, which is my time, okay, that's going to be very simple, right? 100 divided by 100 cancels. I've got 2 zeros, so it looks like 50. So our time for skier 1 is 50 seconds. So it will take him 50 seconds to go 5,000 feet. Okay? So let's go ahead and look at skier number 2. So skier number 2 is traveling the same distance down the mountain. He's still traveling 5,000 feet. And I know we haven't yet considered that his time is going to include an extra 5 seconds. We could include that in the problem, or we can just worry about it later. So let's make it simple. So he is going 5,000 feet, and his rate is faster, though he is traveling 110 feet per second. So if we divide that by 110 and divide that by 110, these cancel. I've got a 0 that can cancel with a 0. And then in my calculator, if I do 500 divided by 11, I have a calculator here. So I've got 500 divided by 11, and that is 45.45. So close that. So in this case, the time is going to be 45.45. But really, that's how long it takes him to get down the hill, but remember that he started 5 seconds later. So this is where we analyze our solutions, right? If we just looked at these two, we would say, oh, well, skier 2 has gotten down the mountain much faster than skier 1. That's true, except for that he was delayed. So we have to add 5 seconds back to his time. So really, with the delay and the time that it took him to ski down the mountain, it actually took him 50.45 seconds to get down the mountain. So what we could do is we could analyze this a little bit closer, because what if we wanted to know how far back skier 2 was when skier 1 crossed the finish line? So we know that if you add on his 5 seconds, it's almost like they started at the same time. So skier 1 crossed after 50 seconds, skier 2 crossed 0.45 seconds later. So we almost caught skier 1. Well, let's think about this. If this is the rate of travel of skier 2, 110 feet per second. If we take this, and skier 1 was 100 feet per second, so we could take this extra 0.45, right, that's the time, and we could multiply it by how fast they're going per second to figure out our distance, right? Because remember our distance formula, distance equals rate times time. So here's our time, and then what is the rate of skier 2? His rate is 110, and since this extra 40.45 seconds relates to him, we could put that in there and say, okay, if we multiply that, we can figure out what his distance was away. So distance equals our rate, 110, times our extra time of 0.45. So we could pull out the calculator for that, and we could say we already have our 0.45 on there, and we could multiply that by 110, his rate, and find out that, oops, I'm multiplying by 45, sorry, let's do that again. Let's do 0.45 times 110, and he's approximately, I'm just going to round, he's approximately 50 feet behind skier 1 when he crosses. Okay, so I use this equation to help me figure out who would cross first. I also use this equation to figure out my distance to see how far back he was. So we have three variables in here: distance, we have rate, we have time. So depending upon what you're given, this is a very important formula. It's used heavily in sciences and in math for different things. So keep that in the back of your head. It's really just a direct variation equation, and it's a linear function. All right, guys, and that concludes our webinar. So make sure that you go back and you post what you've learned or a reflection you have, or maybe how close you were to the actual answer in our discussion. Thanks, and we'll see you guys next week.